Yes, well, hello, Boston. Well, you're probably in this room for one of a couple of reasons. Maybe you didn't want to talk about or listen to someone talk about point-to-point VPN encryption. Maybe you saw the title and thought, I'm never going to move to the cloud, and these guys have something to say about that, so that's going to be interesting. Or maybe you've moved cardholder data to the cloud and you're like, wait, but you said it was safe. In any of those camps, you are in the right place. We're going to talk about confidential computing. I'm going to talk about our journey of how we got there, why we went there, what was important. So Ashok, kick us off.
Well, pleased to meet everyone in this packed hall out here, wanting to know about confidential compute. Very quick introduction from my side. I work in the commerce platform team, and PCI compliance is what I deliver. Brad is a very close colleague of mine. He owns the infrastructure, and we've been on this journey for more than 10 years. And we really want, in this 20 minutes, we want to give you a deep drill down into our journey and what confidential compute is about. And we got our best person here to deliver that to you. Please go ahead, Brad.
Excellent. Thank you.
Next one.
Next slide.
That's us.
All right. So why should we migrate payment platforms to the cloud? If any of you have been in this situation, you know that these are high security environments. Audience participation. Does anyone here operate a cardholder data environment? Several of you operate cardholder data environments. Excellent. And of those of you, how many of you have completed a journey to the cloud, no on-prem, no cryptographic backhaul, everything 100% in the cloud? Almost none of you. Okay, good. So again, right audience, good topic. We're going to talk about those particular customers and what that actually means. So when we looked at our journey and we looked at our high security environment, these things are non-trivial to operate. They are very bespoke environments. They're very complex to operate. And what we wanted, the promise from the cloud, was we wanted agility, we wanted scalability, we wanted ease of deployment. Because when we looked internally, we didn't have those things. We had a very secure environment, and we felt very comfortable with our ability to be compliant, our ability to be secure, but we were hampering the business and the business agility and being able to take updates, being able to take changes. Many of the regulatory changes, the standard updates that are happening, these things cause us to take more time than was necessary to push those things through dev, through test, go through safe deployment, and so on. So this was a critical scenario for us. We needed to be able to move quickly, and we needed to be able to get some of those benefits of the cloud. So as we started to look at those opportunities, we looked at what the cloud was able to offer us, and we didn't find the things that we wanted when we looked in 2018. We didn't see the security features that we wanted. We are also looking at multiple redeployments and refreshments of hardware, and we were up to about $2 million worth of HSM deployments that were coming. So how many of you manage cryptographic asset transfer for your cardholder data environments? Flying HSMs around the world, yes, moving them from place to place, one or two of you. It's no joke. I don't want to be in that business anymore. Putting my engineers on planes with locked briefcases and armed guards and chartered flights. This is one of the things that compromises the agility of these very bespoke environments. The ability for us to deploy a new stamp, to update, to move to a new region, 6 months to a year, right? That's the reality of how to move some of these environments. And so we definitely needed to get out of that position. We needed to get out of the space of being stuck in this on-prem environment. We needed to be able to get there, but we weren't going to do it if we couldn't be confident that the data and the processing of that data was going to be secure. We knew we could be compliant. We knew we could move to the cloud and pass audit. We were not comfortable in 2018 when we started the journey that all the cloud features were there, exactly what we needed. So we started partnering with a bunch of the internal teams.
Yeah, I wanted to echo what you mentioned. One big Achilles heel for us was HSMs that prevented us from going lock, stock, and barrel. And over the years, we've had developments in managed HSM, which really provided the ability for us to think about deprecating our on-prem bare metal machines.
Yep,
Next. And I wanted to invite you to read some of our public papers on this. We've moved around $25 billion of our revenue on which our verticals use a platform for, on this platform that we're talking about.
Excellent. So should I trust any cloud with my confidential data? Well, we're sort of here to tell you rhetorically, you shouldn't trust anything implicitly. Any hyperscaler, sure, we're talking about Azure here, but any hyperscaler is going to have scenarios that you're going to want to address. And so I'm going to talk a little bit about assurance and the levels of assurance that you're going to want to have. And as you're thinking about moving some of your crown jewels, some of your most sensitive cryptographic keys, your most sensitive data, customer data, cardholder data, raw PAN, these sorts of things. Moving that data fully into the cloud outside of the scope of your hybrid on-prem environments, your dedicated on-prem environments, and so on. These are the sorts of things that we were looking at how to manage. And so as we looked at moving that payment gateway, we partnered with a bunch of the internal teams. We looked at what confidential computing was going to offer, and we looked at the Azure Key Vault team. The Azure Key Vault team was building, I'll call it Cloud HSM. The term for us is Managed HSM. There's a couple of different flavors of that solution. How many of you here employ cryptographers on staff to write all of your middleware and your code? One or two, yes. These folks are unicorns. You don't go on to LinkedIn and select from a long list of folks. These are people you've probably may have to pull out of research environments and such. And so we employ very few of these. They're focused in very specific environments. And we wanted to make sure that as we were touching sensitive data, as we were managing cryptographic key, not just transfer, but execution and use, that we were doing so in a confidential and protected manner, because we were looking at moving that stuff from dedicated on-prem hardware that we owned, everything, rack stack, everything, and moving it to a multi-tenant environment. Could we feel confident as a cloud provider, as a customer of Azure, as a customer of the cloud, that we could move those things safely and completely? So a couple of things that we did. One of the things that we said was managing an engineering environment that builds that middleware, that manages and deploys our payment gateway, as Ashok said. This is also one of those non-trivial environments. Any dev managers in the room? A couple of dev managers in the room? So one of the scenarios that we have to worry about is attrition, right? If you put engineers on a project and they're learning a super niche skill and they can't take it with them to their next project, they're not going to stick around for very long. This is something that we can lose sight of if we're just focusing on the product or a program. And so we really wanted to make sure that as we looped our engineering team into this new methodology and into this confidential computing paradigm, that they weren't going to have to learn very niche skills. And so we focused on things like containerization, like Kubernetes, like .NET Core. And so there's a talk later on today about infrastructure as code that I really want to attend. We made confidentiality a deployment time exercise. Our engineers don't have to worry about how to make something confidential, so this is important, right? You shouldn't have to know how to make it confidential. You should know how to containerize and how to wrap the systems and processes that you want to be protected, that you want to have that higher level of assurance. make it a deployment time exercise. So our engineers don't have to worry about writing to a specific C API. They don't have to worry about the specific hardware that they're deploying on. They can deploy independently. We can make a determination at deployment time. Is this going to run as a confidential application in a trusted execution environment, or is it just going to run on a normal pod? So why did we move it 6 months to a year to deploy a new environment? Not acceptable. We had to get to agility. As we started to realize some of these advancements, we can get there in days now. We can deploy an entirely new stamp in a new region in a matter of days. Next.
Well, I also wanted to bring up that we're kind of in a unique position that we're running a merchant CDE footprint inside a service provider footprint, and we are in the same organization which owns both. But at the same time, we wanted to make sure that whatever we are deploying for our merchant footprint is generic enough that we could drag and drop it to another tenant if required. So that was another design goal of ours, to not use anything custom that would prevent the ability for us to multi-tenant the solution.
Next slide. All right. Geez, what sort of precautions should you take? I talked about assurance. Take every precaution. Right? I'm standing up here to tell you we're not members of the product team. We're not trying to sell you on any solutions. The things that I'm talking about today are cloud agnostic. You can run them on multiple different clouds, on different hardware. Intel, AMD are the two most popular ones. Pretty sure we're all in that boat. The scenarios that we're using here, we wanted to make sure that the assurance level of this scenario is going to give us additional capabilities. So let's talk about what confidential computing gives us. We're all familiar with encryption in transit. We're all familiar with encryption at rest, right? Confidential computing gives us that third leg of the encryption in stool. It gives us encryption in use. Right? So again, we're all used to the idea of looking at our data flow diagrams. Where is all of our PCI data passing through? We understand that the data is starting in the browser. It lands on one of our systems and it decaps. TLS terminates, right? TLS stops, and now it's no longer protected on the wire because we're on a machine. We're on a virtual machine. We're running a process. And so in the middle of that business logic, we make some choices, and then we pass it on downstream. We re-encrypt it. We do TLS again. And so as we look at that broad spectrum, we can see that in transit, I am encrypted all the way. And when I finally make a decision to persist that information to disk, I can encrypt it to disk. However, it's those little stops in the middle where confidential computing makes the best play, right? Everywhere that I'm running in a multi-tenant environment, everywhere that I'm running on top of a hypervisor, the confidential computing philosophy here, this technology that we're talking about that's baked into your Intel processors, your AMD processors, and NVIDIA, I believe. This gives us an assurance level that says, this is my code, I'm running it in a particular place, and that memory is encrypted. What does that mean? It means that the hyperscaler provider, the service provider, the cloud provider can't see it, can't see the contents of it. If they crash it, if they crash dump it, they're not able to recover anything out of memory. CVVs, raw pans, we deal with raw pans. If the process is interacting with other systems, then we also have that capability to interact with other confidential computing enclaves. And so this really fills in the gap of encryption in use. It gives us that protection that any hypervisor, any hyperscaler is subject to. The other one in multi-tenant environments that we get super nervous about is VM side channel attacks. And so this gives us an additional layer of assurance that when we're running our cryptographic or payment middleware, we are safe from those types of attacks as much as we can be, and we get that additional level of protection. And again, cloud agnostic. We can move it. It's an open source platform. You can find third-party providers and open source providers that will help you do some of these things. And that's it. Next slide. Let's talk about some of the regulatory compliance scenarios that we see.
So this is the first time, the first line here is, the first regulation that we've seen where confidential computing is called out explicitly. And so we have a feeling that that's where the industry is going, is that confidential computing makes it easier to satisfy your controls because you've built a secure enclave and you can segment test and pen test that enclave, and there's no classified data that can drift out of that enclave. Now, of course, we've cited some other, like GDPR, where the same principles are echoed without that explicit statement. But this is where we are going. We want some assurance that a footprint is built on a secure enclave. It is penetration tested, so the segmentation is confirmed, and thereafter there's confidence that there can be no egress of data that's classified.
Yeah, so we're speculating heavily here, but it's only a matter of time before the DSS and other regulatory bodies, other standards bodies, look at how inclusion of confidential computing technology fits into that compliance and standard for whether it's data protection, data privacy, and confidentiality. So we're anticipating, we're starting to see evidence of this happening, and we're starting to see the industry adopting this more and more. So,
next one.
Next one. I'll talk briefly about the Confidential Computing Consortium. This is an open standards body that Microsoft and other premier partners are part of. We've got our key hardware vendors, the key cloud providers, and hyperscalers in there. Again, cross-cloud, agnostic, and works in a number of different scenarios here. So please go out and take a look at these things. Let's go to our next slide, and
yes,
summary. So in summary, the ability to move your data to the cloud, we really wanted to make sure, as dog fooders of the technology, like eating our own dog food, we wanted to make sure that you can do it because Microsoft did it. We were willing to put $25 billion in payment transactions in the cloud, doing all of our cryptography, all of our panhandling, doing that. Panhandling, that's a new one.
Yes.
All right. So yes, you should be cautious as you're looking at moving it to the cloud, as you're looking at trying to get additional scalability and protection. Look for those additional assurances. You will find options for adopting confidential computing in order to be able to do that. Yep. Your physical HSM footprints, these are really expensive boat anchors, as we like to call them. Consider how you can get ahead of those. We're starting to see more and more of the HSM vendors adopting REST-based interfaces, getting away from PKCS 11. These are things that are more cloud adoptable and that they work much better at scale. Look for those sorts of situations. If you're in the consumer off-the-shelf scenario that some of our partners are in, it's very hard for them to make that jump from PKCS 11 into REST interfaces. We took that jump. We went through and recoded all of our applications to REST in order to fully embrace the cloud. So, moving payment-related services, you can get there. We did it. And that's it. Look for changes in the regulatory and standards bodies, adding and specifically calling out confidential computing. Thank you.
Yeah, I would also invite you to read some of our white papers that we've published where you might see some other application areas like clean rooms or any type of data you're trying to protect in that field. So that's what we had. We probably have a minute or two for questions, but otherwise we're going to be around, so feel free to grab us after this. And I wanted to thank everybody for their participation.
Thank you.